taking.
मैम आप स्क्रीनशॉट मत लेना मैम, मेरा फ्लक्चुएट कर रहा है इंटरनेट, तो लीव हो गया और आपने स्क्रीनशॉट ले लिया तो.
Okay, Sanket. I will be noting your name. So that's not an issue. Okay. So what we have done is the relation between QP and KC, which help in predicting the direction of a reaction, whether the direction is going in the forward direction or in a reverse direction. Okay. Now, if the value of QC is very large, what does it mean? At equilibrium, concentration of products is more or less. Yes. Yes, Himanshu. You want to say something?
Ma'am, have you taken attendance?
No, I have not taken the attendance yet.
Okay, ma'am.
Okay, so if Kc is very large, then what does it mean? If a reaction is A is in equilibrium with B and Kc value is very large, so what does it mean?
Reaction.
It means at equilibrium, amount of products is more. Amount of products is very much greater than the amount of reactants. Equilibrium has reached, but at equilibrium, products is more as compared to the reactants. So all these things we have done earlier. And one more equation I have told you in the chapter equilibrium. Delta G is equal to minus 2.303 RT log K. Delta G naught is equal to minus 2.303 RT log K. So this equation I have told you in the chapter of thermodynamics. It is the relation between Gibbs free energy and log K. Okay, now for a spontaneous reaction, what is the sign of delta G naught, Himanshu? For a spontaneous reaction, what is the sign of delta G naught?
Negative.
It is negative. Okay, now since delta G naught is negative, so Gautam, what should be the sign of K? What should be the sign of K? Gautam? Negative, what should be the value of K?
Positive. I'm positive.
Yes, should be positive. Log K will be positive means K is equal to positive. So it means that for a reaction to be spontaneous, equilibrium constant should always be positive. Okay. Now since Bhavya was asking me on the log, let me take the log here only. See, now as I sent you the screenshot of the class 12 sample paper general instructions, same we are following in chemistry. So obviously what was written that log tables won't be provided. Okay, so what we have decided, more values of log, how to calculate, I will be obviously telling you. I won't be skipping that topic. Anti-log we will be leaving. Okay, now see general for the time being. When we are doing the pH, I will tell you how to calculate from the log values from the table. But just remember the value, few log. Actually, whenever I am writing log, it is the base 10. Okay, these values we are calculating from the table. And what log the base 10? The log 10 is equal to 1. Log 100. If we have to calculate the value of log 100. Yes, someone is saying anything? If we have to calculate the value of log, obviously base is 10. So I am not writing the base again. So there is a rule for calculating the log. Log 100 means log 10 की power 2. Okay? Because log 10 I know, log 10 is 1. So it means it will be 2 log 10. And what is log 10? 1. So 2 into 1 which is equal to 0. So this value you should be remembering. Log 10 is equal to 1. What will be log 1?
0.
0. How? Because what we need is scientific notation. Scientific notation का मतलब होता है कोई भी एक term into 10 की power है ना, 1 digit के बाद decimal. If you remember scientific notation. Suppose I am given 24.15. So I will be writing this as 2.415 into 10 ki power 2, 10 ki power 1. So whenever we are taking the log, we try to convert it into scientific notation. It means 10 ki power. So it means log 1 means log 1.0 into 10 की power minus 1. अच्छा log 10 को okay into 10 की power minus 1. So when I am writing it, what I will be writing? This power I am writing before minus 1 plus log 1. And what is log 1?
मैम 1 को मैम log power 0 भी तो लिख सकते हैं, फिर 0 बाहर आ जाएगा, फिर 0 हो जाएगा.
You can write log 1 into 10 की power 0. ठीक है, तो 0, ठीक है, ये इसको सीधा याद करो log 1 में, otherwise you will be getting confused. Log 1 is equal to 0. Log 1 is equal to 0, log 10 is equal to 1, log 100 is equal to log 10 की power 2, that is 2 log 10, which is equal to 2. If we have to calculate log 1000, more things I will be telling you when we are seeing the log table. Okay, log 1000 means log 10 की power 3. So it means it will be 3 into log 10, that is 3 into 1, which is equal to 3. So these simple values you can remember. Another thing for the time being, you can remember is log 2. Log 2 is 0.3010, log 3 0.4990, log 5. What is log 5?
0.6.
6 further?
0.63.
6.63.
635. Okay, so these values, simple values of the log, you can remember for the time being. Is it okay, Bhavya? Now, suppose you have to calculate, okay, if you want further, suppose you have to calculate log 20. Log 20 means log 2 into log 10. Log 2 into 10. 20 means 2 into 10. So it means log 2.
हम शायद मैम log 5 0.699 होते हैं मैम.
मैं एक बार वैल्यू चेक कर लेती हूँ.
क्योंकि log 4 मैम, क्योंकि log 4 6.012 होता है ना.
वैल्यू ऑफ log 3 में मुझे डाउट है एक्चुअली में.
मैम वो 0.477 होता है
ना. हाँ, मेरे को कुछ लग रहा था. 4771 and this is 0.6990. Okay, log 20 means log 2 into log 10. ये फॉर्मूला होता है log a into b is equal to log a plus log b. ठीक है. Similarly, log a की power n is equal to n log a. So these are the certain formulas. So if we have to calculate log 20, it means log 2 into 20. Now log a into b is equal to log a plus log b. So log 2 plus log 10. So log 2 is 0.3010, log 10 is 1. So 1 plus this is 1.3010. See, is it okay? In the exam, generally it will be log 2, 3, 5, and 10. And if there is certain other question,
forward is not visible.
okay. Is it visible now?
No, ma'am.
Lower part.
Ma'am, the right side. Yes, ma'am. Now it's visible.
Okay. So, but we are not doing log for the time being. When we are doing the PH or when we are solving the questions, then I will be again explaining. So if it's a difficult value of log, value will be given to you. Okay, it's clearly mentioned in the CBSE sample papers. The log values will be given to you, but just try to remember log 2, log 3, and log 5, log 10 also. These values should be knowing for your competitive exams. उनमें और ज़्यादा details होते हैं, but this is a very basic. So for this class, you can simply remember log 2, log 3, log 5, log 10. Yes. Okay, Bhavya? Bhavya, is it okay? Am I audible? भव्या
मैम log 5 की वैल्यू लिखी क्या 699 के बाद
0 6990.
ओके
Okay. So now what I am going to do, we are going to do the next important topic. I will take the question based on this equation when we are doing the numericals. Today, otherwise we are going to do a theory part only. Okay, then I will be taking more and more logs. Now, our next topic is factors affecting equilibrium. And this is governed by a very important principle, which we call as Lee-Chatter's principle. What we are using is the Lee-Chatter's principle. Now, according to this principle, if a reaction at equilibrium, is subjected to a change in concentration, it can be of reactants or products, change in concentration of reactants or products, pressure, temperature, etc. Then the reaction proceeds in This is a new topic we are starting, and please all of you have to try to answer the questions asked. Okay, so don't say that we have missed the previous class. You can do the topic whenever I am telling you the topic, you can easily answer the question. Okay. So if a reaction at equilibrium is subjected to a change in concentration of reactants or products, pressure, temperature, etc., then the reaction proceeds in such a direction so as to oppose the change. What does it mean? If I am increasing the temperature, reaction will proceed in a direction so that the temperature is decreased. Okay. If I am increasing the pressure, the reaction will proceed in a direction so that the pressure is decreased. Okay, I am just taking the attendance once. Akansha, Arav, Agnish.
Present, ma'am. Akansha present.
Ma'am, Agnish present.
Aishwarya, Aman, Anshika.
Yes, ma'am. Present, ma'am.
Anshika, Aryan, Ayush.
Present, ma'am.
Ayush present. Bhavya, Mishra, Bhavya, Bhardwaj, Devansh.
Present, ma'am.
Bhavya, Bhardwaj. Dishita, Gautam Kakkar, Gautam Kumar.
Present, ma'am. Present, ma'am.
Dishita. Okay, mic on hua tha, but Dishita, there's certain problem with the mic, get it repaired. Jayant, Kanak, Kana.
Ma'am, Kanak present.
Jayant, no voice from you.
Ma'am,
I can-
present.
अब आ गया, ठीक है. मानव, ऋषभ, रोहन.
Ma'am,
ऋषभ,
present.
Okay, Sanket is
Ma'am,
present.
present.
Sanyam, Shashwat, Shivansh.
Present, ma'am.
Present, ma'am.
Sayam, Shriya.
Present, ma'am.
Ma'am, Sahil is present.
Ma'am, Aman
Sahil,
present.
So, Sahil, you have joined just now.
Ma'am, I joined. I got disconnected. Few
Okay.
minutes ago.
Siddhant Jain, Siddharth Semwal, Vani.
Present, ma'am. Aman
Present,
present. Ma'am, Siddhant Sharma present.
Okay, Aman. Aman, I have marked. Hand raised, 2 students have raised their hands.
Ma'am, Bhavya Bhardwaj.
Siddharth present.
चल रहा.
I know Bhavya Bhardwaj, you are present. Lakshya was
Siddharth
also
present.
okay.
Ma'am,
Even
Shreya
Lakshya
Mishra
was present.
present.
Shreya also present. Okay.
Ma'am, Vani present.
Okay.
Ma'am, Siddhant Sharma present.
Okay, I am marking it. Okay, so this is the Lee-Chatter's principle that the reaction proceeds in such a direction so as to oppose the change. So now this I am taking with the help of examples and try to understand. It's very easy and it's very much applicable, useful in chemistry in your class 12th also. Now the first one is effect of change of concentration. Now suppose I am taking a general reaction, reactants are converting into products. And the reaction is at equilibrium only. Okay, if the reaction at equilibrium, it means reaction is already at equilibrium, then I am adding something. Now if I add more amount of reactants, what will happen? In which direction the reaction will be going?
Over direction.
Forward.
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 So if more amount of reactants, according to Lee-Chatter's principle, I am explaining reaction will proceed in a direction where amount of reactants is decreased. So if I am adding something, reaction will proceed in a direction so as to oppose. So if I am adding more amount of reactants, the reaction will go in a direction where amount of reactant decreases. Decrease means that is forward direction. Okay. Now suppose I am giving a very simple example. H2 plus I2 gives 2HI. And what we know is that iodine is a violet solid. All of us know. यहाँ पे gas की form में, if I am taking in the form of a gas, what we know is that iodine is violet, this is colorless, and this is again colorless or very pale yellow. So what will be the color on the side of reactants? Overall color. If I am adding hydrogen plus
Violet.
iodine, violet, because iodine is violet.
It will be violet.
Very good. So it means that if more iodine is present, more will be the intensity of violet color. Okay. So it means that intensity of violet color depends on amount of iodine. Intensity of violet color depends on the amount of iodine. I hope this point is clear to all of you. Okay.
Yes, ma'am.
Now my question is, because we have to do the questions based on this. Now my question is, question, H2 plus I2 gives 2HI. What will be the effect of on intensity of violet color? Shreya, you will try to answer first part. What will be the effect on intensity of violet color if first part more H2 is at I2 is added at equilibrium. Second part HI is removed at equilibrium. More H2 because more H2 and I2 are added at equilibrium. Third part HI is added at equilibrium. The reaction is at equilibrium. So in the first part Shreya will do. Second part Sanyam will tell. And third part Jayant you will tell. Now first part, if I am adding more amount of reactants at equilibrium, what will be the direction of the reaction? Shreya.
Ma'am, forward.
Forward. So what will be the intensity of violet color? The reaction will proceed in forward direction. So what about the violet color? Will it increase or decrease? Forward means they are reacting to form HI and HI is colorless. So what about the intensity of violet color, Shreya? Will it be more or will it be less?
Ma'am, I guess
मैम it will be not मैम मिडिल में रहेगा थोड़ा.
देखो, अगर मैं आयोडीन डालती हूँ, आयोडीन का कलर होता है वॉयलेट, तो इफ आई एम एडिंग मोर अमाउंट ऑफ iodine, reaction is going in forward. Forward means it is converting into HI.
Yes मैम.
आयोडीन तो खत्म हो गया ना, रिएक्ट कर गया, तो वॉयलेट कलर क्या होगा, कम हो जाएगा. जैसे मैंने iodine डाला तो वॉयलेट कलर एकदम बढ़ गया, but the reaction will proceed in the violet color so that the will proceed in the forward direction. ठीक है, forward means it is converting into HI. So it means intensity of violet color decreases. Is it okay? So this is my first part. Now in my second part, HI is removed. It means we are removing HI. So according to Lee-Chatter's principle, if we are decreasing something, reaction will proceed in a direction so as to oppose. It will try to increase HI. Okay, so what will be the effect on intensity of violet color? Second part. Yes, I asked a student, Sanket, Sayam, Sahil. All
Ma'am,
three.
it will decrease.
Intensity of violet color will decrease. Okay, so if HI is removed, so it means second part means reaction will proceed in a direction. I am explaining this part. Second part, reaction will proceed in a direction. Decrease so as to increase constant amount of HI, that is forward direction. When the reaction is proceeding in the forward direction, so it means iodine, these will more amount of H2 and I2 will react. Only then the reaction will proceed in forward direction. So intensity of violet color decreases. Third part, Jayan. Jayan, say yes, ma'am. HI is added at equilibrium. Jayant.
May I?
Okay, you can tell.
May I?
Ma'am, it will go in forward direction and the intensity
It
of
will go
color
in
will
reverse
decrease.
direction.
Ma'am, may I?
Ma'am, it will go in backward.
Ma'am, yes, ma'am, it will go backward and as such as the and as such as the violet of I2 will intensity of violet will be decreased.
Yes, very good, Aryan. Okay. Now just see again.
Ma'am, violet to increase होगा ना.
Okay, if HI is added at equilibrium, it means that if I am adding more amount of HI, so reaction will proceed so as to decrease amount of HI. If I am adding something, it means reaction will proceed in a direction so that HI decreases. Decrease, it means backward direction. Backward means towards
Violet will increase.
towards reactant. So what about the intensity of violet color?
It will increase, ma'am.
So amount of HI decreases backward. Backward means towards reactant side. Towards reactant side. So H2, so intensity of violet, yes, पहले शायद उन्होंने उल्टा बोला था मुझे. So intensity of violet color increases. Okay, Aryan?
सेकंड वाले में इंक्रीज है कि डिक्रीज?
Ma'am.
सेकंड में डिक्रीज है. मैंने एरो डाला था एक्चुअली में इस तरह से. So the second वाले में decrease है, first में भी decrease है, but in the third case, because the reaction is going in backward direction, so the intensity of violet color increases. Is it okay? Now there is one more interesting case here. These are somewhat related to, few points are related to your practicals, and since they are given in NCERT also, so I am taking this reaction. But I am taking in the form of question only, okay? I am rubbing the question. SCN means we can have potassium thiocyanate. This is a test for iron when we are starting with the test for cations. In this, you will be studying this test. So iron is a cation which react with any of the thiocyanate. It is generally potassium thiocyanate. And what we get is a deep red color. What we get is this complex. FeSCN charge will be 2+. Okay. Now ferric solutions are very light green in color. All of you know iron salts like ferrous sulfate, ferric sulfate, they are very light green in color and or reddish brown. And but this color is having a blood red. So I am studying the colored comprehensions. Okay. The color of the ferric thiocyanate is deep red or it is blood red. Okay. Now, first point. Okay, just remember one point on adding. Okay, let me give you the question. On adding oxalic acid, if I am adding the oxalic acid, okay, on adding oxalic acid, concentration of Fe3 plus reacts. And its concentration decreases. Just remember this point. Okay, on adding oxalic acid, suppose I am giving a reactants are ferric chloride and sodium thiocyanate. And what we are getting is this compound, which is of the blood red. This equation is clear given to you. This point I am telling for your information that on adding oxalic acid, ferric ions reacts and its concentration decreases. Now my question is first part. Question is what will be the effect of on intensity of blood red color if first part ferric chloride is added to the equilibrium mixture. Mixture is at equilibrium, and if I am adding ferric chloride, Kana, can you tell me? Kana, ferric chloride is added. I think your mic is not certain problem. Your hand. Okay, Rohan, can you tell me what will happen if I am adding ferric chloride to the equilibrium mixture? Next question, Siddhant Sharma. Yes, you can tell me stepwise. If I am adding ferric chloride means Fe3 plus. Ferric chloride means if I am adding is Fe3 plus. Forget this point. If I am adding is
मैम क्लोराइड के साथ क्यों रिएक्ट करेगा?
जब मैंने फेरिक आयंस मैंने ये इक्वेशन को मैं इस तरह से भी लिख सकती थी फेरिक आयंस प्लस पोटेशियम थायोसाइनेट एंड व्हाट वी आर गेटिंग इज पोटेशियम फेरोसाइनाइड. इस तरह से आई कुड हैव रिटन इट लाइक दिस आल्सो. ठीक है, मैंने आयनिक फॉर्म में इक्वेशन लिखी है. फेरिक क्लोराइड मींस फेरिक आयंस. फेरिक क्लोराइड मींस फेरिक आयंस. फेरिक क्लोराइड का कोई रोल नहीं है. क्लोराइड कई बार हम ऐसे भी तो होते हैं विच आर नॉट टेकिंग पार्ट इन द रिएक्शन, जो हमारे बच गए. तो क्लोराइड आयंस का कोई भी रोल नहीं. पहले भी हमारा फेरिक आयंस मींस फेरिक क्लोराइड आई हैव एडेड. तो सिंपली इफ आई एम एडिंग
आयंस का अमाउंट बढ़ जाएगा, फिर रिएक्शन रिवर्स हो जाएगा, यानी कि Fe मतलब फेरिक साइनेट वो
जस्ट टेल अगेन किसका अमाउंट?
reactants का.
Okay, so amount of reactant increases. First point, very good. Then in which direction reaction will proceed? Forward or backward?
Forward.
Okay. Forward. Reaction will proceed in forward direction. Okay, so what about
blood color और dark हो जाएगा वो red.
Intensity of blood red color increases. Is the point clear? Okay. Now second part, if I add Let me take the NCRT part only. Okay, let's take it easier one. If I add Fe SCN2 plus or Cl2 to the mixture. See, these are the ionic equations. यहाँ पे FeSCN2 plus means 2Ca2 minus और यहाँ पर हो गया 2 plus. So if I am adding FeSCN Cl2 to the mixture, or if I am adding products to the mixture, then who is going to tell me? Siddhant Sharma, I asked you, or Dishita then? Or Siddhant? Yes, Siddhant Sharma. You're not answering anything. Anshika, are you present? Because I am going to tell your parents that you are always switching on the mic, switching on the, simply your name is showing, but no response. Dishita, are you there?
May I?
No, not you. Dishita? At least you can say yes, ma'am, Dishita. Okay. Next, who can tell? Shreya, no, Shreya, Shivansh. Yeah. Shivansh. Dishita, if you present, just say yes. If not, then I will understand. Yes, Shivansh. Devansh. These students are not.
Yes, ma'am.
Devansh, you tell me.
I just wanted to confirm the third part. So I will talk to my manager and. Ma'am, in this question, I don't know. Ma'am, addition of I will increase or decrease the product.
If we, I means if we add. Okay. If we are adding this to the mixture.
Ma'am, then backward reaction will occur.
So if I am adding products to the mixture, then reaction will proceed in backward. What about the intensity?
Ma'am, intensity of red color will decrease.
Yes. Intensity of red color decreases. Okay. Now third part. If we add oxalic acid, this I gave you purposely. If we add oxalic acid to the mixture. Now, one of the important tip I have told you, because you have not studied it earlier, that on adding oxalic acid, the amount of ferric ions decreases. So what happens if we add oxalic acid to the mixture?
Reaction
direction.
will decrease backward direction. Ma'am, it will go in the backward direction because Fe3 plus will decrease the concentration.
1 minute. If we add oxalic acid to the mixture, then amount of Fe3 plus decreases. Okay.
Yes, ma'am.
Yes, ma'am.
So if the amount of Fe3 plus decreases, then the reaction will go in which direction?
Ma'am, the reaction will go backward direction now.
Yes, very good. So the reaction will proceed in backward direction when the amount of Fe3 plus increases.
Ma'am, the intensity of blood red will decrease.
Okay. So let me write. So on adding this one, the reaction will go. I am rubbing this one. So amount of Fe3 plus decreases, reaction will go in direction, in backward direction, where the amount of Fe3 plus increases. Backward direction. So intensity of blood red decreases. Is it okay?
Yes, ma'am.
Okay. Now there is one more part. This is NCRT actually solved the example to explain. Fourth part, if we add HgCl2 to the solution, if I add mercuric chloride to the solution, write in bracket Hg2 plus reacts with, write in bracket Hg2 plus react with SCN minus. This is suppose you are knowing, or I am giving to you for the time being, but please do this example because this is an NCRT illustration. So if we add HgCl2 to the reaction solution, and I am giving you a hint, Hg2 plus reacts with thiocyanate. So what happens?
Ma'am, backward reaction.
Ma'am, the reaction will proceed in forward direction now.
Same case is also, if I am adding oxalic acid, Fe3 plus reacts. If I am adding HgCl2, thiocyanate reacts, the amount of SCN minus decreases.
Ma'am, the reaction will go in backward direction then.
Amount of SCN minus decreases. The reaction will go in backward. So intensity of
and
color.
the intensity of blood will decrease.
Yes. Is it okay? So this is a particular example which is based on color. So just go through the example. It is a NCRT illustration. Okay. So these points are new for you. So just try to remember the points. Okay. So first, what we have done is the effect of change of concentration. Now the second point is effect of change of pressure. Second point, effect of pressure change. Effect of pressure change. Now, what is the pressure? Pressure is due to solid, liquid, or gases?
Ma'am, due to gases, sir.
Pressure is basically due to gases. Okay. So if we increase the pressure, reaction, if I am taking general reaction, reaction will go in direction where pressure is increased or decreased?
Decreased.
Decreased. The pressure decrease means where there is less number of gaseous moles. Pressure is due to gaseous. So it means where there is less number of gaseous moles. So where there is more gases means more pressure, less amount of gases means more amount of gases means more pressure. Less gases means less pressure. So we generally, the solids and liquids are independent of the pressure. Okay, we ignore the pressure for solids and liquids. For solids and liquids, because we are taking their concentration. For solid and liquid, we take their concentration and it is independent of pressure. Now, suppose I am taking this Habers process, N2 plus 3H2 gas gives 2 ammonia gas. Okay, on adding more amount of N2 and H2, what will happen now? On adding more amount, Arav Sharma, on adding more amount of N2 and H2, what will be the direction of the reaction at equilibrium? Yes, on adding more amount of N2 and H2. Akshita, can you tell me, Akshita? Kanak, I will ask you afterwards. Just let me ask Akshita. Akshita, I marked your attendance. Okay, Akshita is not there. Are you?
Ma'am, she told me her mic wasn't working in the last class, so maybe her mic isn't working right now also.
Okay. Aman, can you tell me, or Aishwarya, you only tell in our place, on adding more amount of N2 and H2, in which direction the reaction will go?
Ma'am, in forward direction.
ये इसको ऐसे मत करो, N2 और H2 की टर्म्स में. Okay, let's do in one more way. ये तो इससे ही हो जाएगा ना आपका. On increasing the pressure. Okay. वो तो आपको concentration के ऊपर ही हो जाएगा. On increasing the pressure. If I am increasing the pressure, what will be the direction of the reaction? If I am increasing the pressure. Aishwarya, not
Forward.
reaction.
Forward.
Yes, reaction will proceed in a direction where
There is
pressure
less.
decreased. Decrease means towards products. Okay. Now, if I am taking this reaction, suppose calcium carbonate dissociates to form calcium oxide solid plus carbon dioxide gas. If the pressure increases, then what will be the direction? If I am increasing the pressure, Akansha?
I'm backward.
What? Backward.
Backward.
यहाँ पर pressure ज़्यादा है, यहाँ पर more pressure है. You can write here more pressure, here there is less pressure. So if the pressure increases, reaction will go in backward direction. Okay, so this is the effect of change of pressure. Now what we know is another thing. Okay, one more example. Or is it clear? Then I will take in the question. I think it's clear. Only effect of pressure. The reaction will proceed in a direction where the pressure is decreased. Okay. Now I am taking another first, okay, effect of concentration. Second is effect of pressure. Third point is effect of temperature. Effect of temperature. Now just keep in mind, if we decrease temperature, reaction will go in exothermic. Exothermic means where energy is released. Exothermic means where energy is released. And whenever the energy is released, so temperature increases. Okay. So if we decrease the temperature, reaction will go in the exothermic direction, and vice versa. So if we increase the temperature, means reaction will go in endothermic direction. So in this, we have to see whether which direction is endothermic and which is exothermic. If we decrease the temperature, reaction will go in a direction where the temperature is increased. Okay, that is the exothermic direction. So if I am taking, suppose this reaction N2 plus 3H2 gives 2 ammonia, and what we are getting is delta H is negative. What is the meaning of negative sign?
When that energy is released.
It means the forward reaction backward reaction will be endo. Energy is released in the forward direction. Negative means in the forward direction energy is released. That is, forward direction is exo and backward is endo. Okay, so question is, what are the conditions in terms of pressure and temperature to increase production of ammonia? If in the Habers process, this is called as Habers process. You should be knowing what is Habers process. So in the Habers process, if we want to increase the production of ammonia, what should be the conditions in terms of temperature and pressure?
Increase the pressure and decrease temperature.
Pressure increase, temperature decrease.
In pressure, so that the reaction will go in the direction where the pressure is decreased, that is forward. Okay, second is, what about the temperature?
Decrease in temperature.
Decrease in temperature. So if we decrease the temperature, reaction will go in exothermic. Exothermic means forward. In this case, it is given that is forward. In this case, it is mentioned to us. Okay. Now, if
What
I
has written in the question?
On the
question
first line after the
what are the conditions in terms of pressure and temperature to increase production of ammonia in Habers process?
And that means to decrease.
To increase the production. Increase the production of ammonia means forward direction. In the forward direction only ammonia is increased. So if I am in terms of pressure, here we know is that there is less pressure. Less number of gases moles, here there is more pressure. So if we increase the pressure, reaction will go in the direction where the pressure is decreased. Where the pressure is decreased, forward. Okay. Second point, if we decrease the temperature, reaction will go in the exothermic direction. For general, if we decrease the temperature, reaction will go in a direction where the temperature is increased. That is exothermic. So
Ma'am, but if the reaction is giving off energy, then its temperature will decrease now, more decrease. Then why?
बेटा टेम्परेचर बाहर तो बाद में जाएगा ना, सिस्टम हीट अप हो जाएगा ना. वो तो जब इक्विलिब्रियम से डिस्टर्ब होगा, when it is losing it to the surroundings only, then it will decrease. Otherwise, अगर मेरी कोई भी if I am taking a test tube, I am doing some reaction. Suppose I am adding sulfuric acid to water. Test tube becomes hot. Yes or no? It means temperature of the system is increasing.
Yes, ma'am.
Okay, we are not surroundings. We are not talking of the surroundings. We are only talking of the system. Okay, now suppose I am writing is A plus B plus heat gives C. What does it mean if I am writing it like this? A plus B plus heat gives C. What does it mean? Whether the forward is endothermic or exothermic?
Endothermic.
Endothermic. Exo.
Forward is?
Endothermic.
Endothermic. Endothermic. Okay. It means it is absorbing heat. So forward is endothermic and backward is exothermic. Okay, so you should be familiar with if I am writing like the heat means it is absorbing heat. And one which absorbs heat is endothermic, which releases heat is exothermic. So in this case, if temperature increases, then what will be the direction?
Backward. Backward.
If we are increasing the
forward. Endo
No, ma'am, forward, forward.
Reaction will be forward.
reaction will go in forward direction. Forward means endothermic. So if whenever the temperature is increased, just keep this thing in mind. Whenever we are decreasing the temperature, reaction will go in exothermic. And whenever we are increasing the temperature, reaction will go in endothermic. So you should be knowing what is the endothermic direction and which is the exothermic direction. Is the point clear?
Yes, ma'am.
Okay, just
मैम इंक्रीज करने पे एंडोथर्मिक पे जाएगा ना.
Then we consider it.
हाँ, डिक्रीज करने पर एक्सोथर्मिक में और इंक्रीज करने पे एंडोथर्मिक में.
Ma'am, it will be given.
It will be given in certain way. It will be given to you.
मैम बट ये होता क्यों है कि टेम्परेचर इंक्रीज करने पे वो decrease हो?
क्योंकि बेटा किसी चीज का मैं टेम्परेचर इंक्रीज करूंगी टू अटेन इक्विलिब्रियम, इट विल गो इन अ डायरेक्शन वेयर द टेम्परेचर इज डिक्रीज्ड. यस और नो? लीच-एटलेस प्रिंसिपल दैट अगर आप सपोज यू आर टेकिंग एनी वेजिटेबल, इफ यू आर एडिंग सॉल्ट इन एक्सेस, so what you have to do? You have to remove the salt. So it means anything wants to attain equilibrium. So if I am adding increasing temperature, the reaction will try to neutralize this. How? By decreasing the temperature. Decrease means endothermic direction.
हम जनरली जो एक डिकम्पोजिशन होते हैं वो एंडोथर्मिक होते हैं ना.
किसका? किसकी composition endothermic? Can you repeat the
decomposition reactions?
Decomposition. Generally they are endothermic. Generally, but not always. Generally. Okay. So with this, today's class is over. Tomorrow I have first and second period will be of chemistry. You can leave the class.
Thank you, ma'am.
Have you taken attendance?
Yes, I have taken the attendance.
Thank you, ma'am.